what I'm actually working on. So at the moment, I have been working on, let me share my screen. I'm not sharing. Where'd the Zoom button go? I hate when I lose my Zoom button. There it is.
Nice.
So my motor is mounted, and it's under digital control. I have the base program that you had provided. My difference is that my steering is controlled in one Teensy, and the transmission will be controlled in another. So this is largely all around the steering control. This is a plot from trying to get my PID tuned. I have used, that's not what I want to show. I thought I had my Ubuntu machine fired up. I am still trying to get this PID working, and I'm close to giving up, but I haven't given up yet.
When it oscillates like that, sometimes your p-value is too high.
Yeah, and so what's scrolling across the screen
Or
are
all the different tries.
the 42 different tries that I have up to this point attempted. And so I've got to come to the point of whether I'm going to continue to try to figure this out, or give up and go to just the KI value that I think is embedded in your original code. So this particular library, PID library, gives you these variables that you can use. You initiate the PID with this command. You vary the values with that command. This is what my steer base function looks like. So you give it a set point, you provide the input, it runs its thing, and it provides an output, and that's the steer effort. So that's the mechanics. It also allows you to have a outputs limit. I think I put the output limits in my setup. So my output limits are set here, which I use the variable max steer effort, which I have set at the moment of 50.
Yep.
And so the results of all of that, this is not all of them, but these are sort of the last few that I've done. This was not acceptable, so I made changes. This, wouldn't settle down. This was a fantastic, going from there to there was fantastic, but then going up a little bit more provided, vacillating results. That was rotten. That was cool. That was rotten. This time period, so it was pretty slow to get down there. This time period to get there was, I thought, fantastic, but again, it vacillated. This time period was a little bit long.
So you seeing a trend left to right, a longer delay going one direction than the other, like that?
I believe so. That was a hypothesis. I didn't actually put pen to paper. I was just trying to get it more stable before I worried about fixing that problem. This one was pretty damn cool. Then it comes back up and vacillates. This one comes down and vacillates. So that's like odd that it would be so different. And so that's where that's where I've ended up. So at the moment, I'm sitting there with, my documented 40 whatever second try, and my KP, KI, and KD at those levels. I had kept my KP pretty constant, and so then I just started to adjust the KI to see if that would help me out at all. And so this is where, a friend would say, knock it off, Al, just use KI like like we're using with the I call it out of the box code that you've already got, and give up on trying to get this PID working. But that's
it just depends if you want to learn how to do it. It's neat. The PID algorithm is a very powerful very powerful.
These oscillations, any friendly advice you want to offer on how to smooth out those oscillations?
So there's like a little algorithm that I generally use. I was taught how, and you're going to get different mileage depending on your system. But basically, you set all values to 0, and then you slowly increment your P until, you're going to see the graph, but it'll just start to oscillate. And then when so you're going to crank it up slowly. It's going to slowly approach the line, and lazily get there. And then it's going to overshoot the line, and then it's going to oscillate. And then at that point, then the KI is like, then you dampen it. Then your KD is like somewhere between a half. So you take whatever your P value is, and then just divide that by 2. And that's your KD value. Or you may need to drop that down by a 1/4, somewhere around there. And that will take out that will dampen it.
And although, I don't have a lot of them documented here, I was trying to follow that model of, just do KP. And I mean, maybe it's worth trying to go back and spending some time on that. But
so the PID, each one of those is sort of like its own little control algorithm. And so the P will work. Like you can just use a P out of a PID and put everything else to 0. There's reasons why you want to dampen it, and then the I is mainly used if there's force against the system, and you can get back online. But it's amazing how much you can tweak those values and not get it stable. Like an auto tuner would be sweet to add into that.
Yeah, maybe I just didn't keep at it long enough on the P itself.
Yeah.
Output is the steer value, right? So we're shooting for, in my case, 50 is the max. And I could, I could only get it to get to this, which is not going to move the motor.
Well, so like with your P value, if you're slowly ratcheting that up, you're like, if your P value is too low, it won't go towards this. It won't even move it. And then you slowly move it, and then it will approach. And if it's really low, it'll take a long time to get to your set point. And then like it'll like approach it like an asymptote. Not quite get there, and be super slow.
I didn't do a good job of documenting what was the results when I, made it. I think it started, that was the highest p-value, 0.05. And the only thing I wrote down was overshoot.
Perfect. So you want to play right around to that to where it's starting to oscillate or overshoot. If your p-values are too high, it will go, up and above your set point. You just want to dampen, you just want to do it just so it's a little bit. If it's too low, it'll never approach your set point, or it'll take forever.
And on your transmission control, I don't remember, do you have a full PID on your transmission control, or did you just use the KI as well?
Yeah, I don't. I just do it as simple as possible. So we can take a look at that one. Have you started working on velocity, or are you just working on steering?
Yes, purely on steering.
Yeah, so steering, I just use an integral. So I'm just, okay, so I'm not totally, because I'm adding in the air. It's a P and an I.
Well, here's what this is the August version that I have from you.
Okay, yep. So we're back on steering. I don't know if you want to talk about velocity or steering.
Well, I was wondering, in your velocity, did you say, so for velocity, you've got this, so you've got a P, I guess it's all of that, right?
It's just a P and an I.
Yeah, here's your KI. It's one of those torturous examples of, I don't want to give up, but then I'm like, just do what works.
I mean, having a full PID is pretty neat. Having in the Lino robot, his PID is nice because you can adjust the values through the dynamic reconfigure.
Yeah, I saw that. I tried to actually get that to work, but I couldn't. I think it was using the RQT plot and an input screen on RQT plot, and I was not smart enough to figure out how to get that to work. So anyway, that's where I'm at. I might try one more time with the KP to see if I can get it to behave any better with just the P, and continue the tuning.
And just kind of interesting, it looks like a different, like sometimes when I don't know if it's going to the left or right, but when it goes, sometimes it's a pretty nice, it gets there nicely, but other times then it sits there and oscillates.
Yeah, here recently, I mean, this is the best that I've had.
Yep.
But you can see that was preceded by oscillation, and after it oscillated as well.
That's interesting. So then, what are you plotting here? You're plotting your angle data and set point?
Yeah, so angle KLM is actual angle going through a Kalman filter. So that's the oscillating line is actual angle filtered, and then target is, as you might guess, is the set point.
And then sometimes it's nice to take a look at the control output and see if you're maxing on that 50 or what's happening. What are you sending to the motor?
Yeah. I think given my axes over here is, on average 36,000, the output is going to be, 0 to 50.
You have to have a separate plot.
So you just start another window.
Yep. And you're really looking for it. Is it getting truncated? Is there something happening to that signal that's causing those variations?
And all of that's going to be inside of the PID.
Well, I'd be curious to see what you're sending to the motor. What's the output PWM command, the final. There's something different between these three set points.
You mean what's the value?
Yep.
Yeah, so just to clarify, the output out of the PID is that variable. It's effectively the steer effort to continue to use the code that's already been written.
Yep.
So you're suggesting plot that steer effort.
Yep. It could be that you're maxing out. So if steer effort's above your max steer effort, then you're going to use the max steer effort. And I'm curious on that one set point that was really smooth, if let's just say I'm making up numbers, your max steering is set at 50. And so maybe it was outputting 0 to 25 and that's why it made it. And then maybe on those other two set points, it was outputting actually like 75 or something. And so it was peaking and causing you to overshoot. So I don't know, these are just guesses, but sometimes I like to see what is the actual command going to the motor to try to just understand what is the implications and what's the output be.
Yeah, I think I might have to switch back to your logic because that question, the way this PID library is written is you can actually tell it what's the max and min that you want the output. So it's filtering. If it is filtering, I don't know why or how, because that's all embedded in this class, which is a part of its library.
Okay.
So it will never, obviously assuming the code is working correctly, which no reason to believe that it's not, it will never produce anything greater than 50, which is what I've got the max set at.
So let's say that for whatever reason it's not analog, that you're peaking for whatever reason, those values, those numbers are setting in, it sends this thing to 50, the max output.
Mm-hmm.
And that's why it's oscillating on one, but at this set point, it's smooth, and at this set point, it's oscillating. Because the reason is because the inputs, this is a guess, I don't know, but the inputs are causing it to be max at this level, but at this set point, it's not max. And so you get an analog control. It's not truncating your edges.
Yeah, it's definitely a good tip to open up another window at least, maybe two, to track, output as well as, I'm already tracking these two things, right? So I'm just not tracking the actual steer effort. I'm posting it. I'm writing it in an info statement here,
Yep.
but I'm not putting it. It's a variable, right? And I'm putting it out in my output, but I'm not publishing it so that I can. Can you publish a variable?
Yeah.
Or can you plot something that you're not?
Has to be a topic.
So I have to create a topic and put that out there.
Yep. It's the Ross way.
It's the Ross way.
We shove everything in topics.
It's It's okay. I know how to do that.
But the buffer is nice too. That's the quick way.
Well, again, for me, I just wanted to make sure something was going on, and that was helpful to be able to do that.
It's cool.
So that's what's going on in my world. But you sent me a video from the guys in Argentina, and it looked like they have got their steering tuned.
Yeah, it didn't change anything. Just left, right, and it just goes to that position.
Do you have a picture of how they mounted the potentiometer to the shaft of the steering motor?
Yeah, that steering motor goes all the way through. So you have the top one, which you looked at doing before. And so it's made a housing and then taped it on there. And then so as that shaft turns, then they can measure it.
And which potentiometer, or what? I mean, was it an encoder?
No, it's just a 3-turn 2K potentiometer. $5. It's not waterproof, and it only has 400, or is it 400 or 600 ticks per full range, but it seems to be good enough. Like, I haven't moved that down into angles, how many ticks per angle, but it's smooth. Never had a problem with it.
Awesome. Okay. Welcome, Jeff.
Hi. I got tied up in something. I forgot the meeting was going on. So I thought, oh man, it's time. So I fired it up.
No, we're glad you joined.
So you're probably looking to know what's new in my world. Well, I blew up my robot last night. I took it over to the robot meeting. I was driving it around. I was bored. So I told the guy next to me, these floors are dirty enough. There's not much friction. What happens if I run a full speed forward and slam it to full speed reverse? Well, it did. It went screaming across the floor and came to a stop, and the tires turned backwards a little bit. And then I noticed my joystick wasn't working anymore. And I went over and looked at it, and there was no power. And so it at least blew out a fuse. And I think I had a 10-amp fuse in it. But I was thinking there should have been some other lights on. I don't remember any lights, so it could be it blew up the next fuse up line. I think I had either a 20 or 30 amp fuse coming right off the battery, and this is my 10 amp fuse. And I think if I look at it, I pull out a meter here while we're talking and check it. But I'm pretty sure this fuse is blown out, and I'm hoping so, because I'm hoping I didn't blow out everything doing something stupid. That would be really annoying. So anyway, I have to get that fired up again and see what I screwed up on that. And the other thing going on is we did get our parts. We started on a robot here today at work, or we started on it, I think yesterday, started putting the wheelchair motors onto a frame, and they were actually driving it around today. So that's kind of where that's going. I guess that's the two major things I know about.
What are the wheelchair motors going to be connected to?
Oh, they've got a, hold on a second.
It's like the scissor lift.
It's just a like 80/20 frame, and it's got two wheelchair motors on it, and it's got two caster wheels on the back. And the thing sticking up, that's some little forklift forks that they stuck on there that are hinged. So that's just part of it is one's holding up the orange flag so we could drive around the office without people tripping on it. So that's where we're at on that. So
it's a test bed platform for you.
basically, yeah. So they could put sensors on and partly put on their fancy display, and put the Danfoss parts on it, and say, so you can see the parts and say, this is what we're doing, this is how we're testing all our stuff. And so that's what it's going to be. And we haven't got into it very far, but So I'll be working on that probably the rest of the day.
That's awesome.
And then, of course, when you say we're going to build something like this, they start asking around, and Danfoss bought a company, that Akuzi remote control company. Somebody said, no, we didn't actually acquire them, but somehow we're mixed with them. And then another person said, no, we bought them. So I don't know what the story is on that. But anyway, it's an industrial control. So it's the remote control you carry around, kind of like my little one in the plastic ammo box, but it's an official one. They're probably $3,000 or $4,000 a piece. So then you basically just take the receiver and bolt it onto the machine, and I think it's got an e-stop relay, and it's got the CAN bus coming out. And then that just gets wired into your, they picked what they call the Danfoss high power controller, which puts out, it's got 2 channels that are 25 amp H bridge and 2 that are, I think, 15 amp H bridge. So they took the 2 25 amp channels and hooked them right up to the wheelchair motors. And just by running the joystick, then by put a little bit of code, say take the joystick and multiply that by a scale factor, run the PWM there. He was able to drive it around here, and we'll see how well it's going to work. So that's the only thing that I can think of that came up that I need to tell anybody about. So
Cool. Matt, anything you want to share in the robot business?
The robot business. Working on this. Some people want to automate a lawn tractor, and I was like trying to figure out a pathway to learn how to do this that's a little bit easier. And so that's why I posted in the Ross channel about, being able to read a sensor and control a motor. Does that make sense as like a small enough work? It can be a lot of work just getting Ross installed and then getting things up. But then last night I was thinking maybe, like Jeremy posted, just create a Docker container, and then maybe people don't really need to learn the full Ross. Maybe we just put all the software in there, and then they have to put the components together and then just use Ross, and maybe start there, and then they can work backwards. If they want to make a topic, then they can learn how the topics work. What are your thoughts on that? You guys have been plugging down a road, an endless, easy road to use Ross for a while.
Jeff, you want to start?
Well, I'm kind of at the same point I am where, somebody walks up and asks an electronics question. I've been doing this stuff forever, and I really can't relate to somebody that knows nothing about it. And that's kind of, when you first say, well, how do you approach Ross? And that's kind of the same situation I'm thinking of here. Where do you start? And I guess my approach was always, if you're trying to learn Ross and trying to just get something to run, there's enough tutorials out there that you say load Ross, and then you have to have a vehicle that has like say this thing right here that I can see it in the picture in the background, where it just had the two motors with the encoders on, and then it's got the laser scanner on the top. And there's enough tutorials out there that it's got the Raspberry Pi that says talk to your motor driver and make the wheels turn, and then use the laser scanner to do maps. And so that's, if you just say, if you've got a basic vehicle that you can control the motors, and even without a laser scanner, if you just want to drive around, say with odometry or whatever, if you, again, just have a basic level that says, when they set up Ross, they said, we're going to make this, compatible, or they're going to standardize it. So you've got the command velocity message coming out, and it's up to you to convert that into whatever it takes to make your vehicle run. And as long as you've got an example of, say, to do a differential drive or an Ackerman drive, it's not that hard to go between there. But they got that nice dividing line that says the software generates command velocity, and then it's up to you to make that run. And then likewise on the odometry coming back, if you go through the examples of various different platforms, they say, here's how we generate our odometry, and that's just a standardized message that the Ross needs. So at one point, you can say that is in order to load ROS and get it to do something, that's seems like a fairly good way to go there. Now, as far as putting the entire package together and saying, here's an entire, say, lawn tractor that you just take it out of the box, take the software, load it on, you do these modifications, your lawn tractor, and you'll have a fully operational machine. There's a big step in between there, but as Matt says, you can present one thing, you can always work backwards. So that's without putting a lot of thought into it, that's kind of my thoughts on that, I guess.
I guess just to add to Jeff's thoughts, Matt, if somebody said they wanted to do it, I mean, today the reality is you're effectively saying, hey, I want to be a developer and I want to create something, because there's not something you can go buy and just use it, right? So they have to have their head around the fact that this is a development exercise, and what elements are they comfortable developing? I think what Jeff showed is that two-wheel deal was a fantastic way for somebody to start to say, what's robotics? But if I were using the metaphor of a railway map, and you're trying to get from New York to San Francisco, well, in their skills and learning, are they in New York, or have they made, are they can get on in Kansas, right? Bringing that to a practical level, I think it's cool to think about giving them a simulator and saying, can you load up the simulator and get the simulator running purely all software without any hardware? To me, that would be somebody that's in New York. Hey, can you get the simulator going purely from a software perspective? I think that's a fantastic place to start.
Okay.
But if they've got those skills, if they can fire up a machine and use a joystick and drive a simulator, then you can move them to, okay, so let's talk about the physical world. And then using a platform like Jeff held up there to say, okay, I'm not going to do this in ROS. We're going to do it in whatever proprietary operating system there is, or maybe there is a ROS system designed for that. I guess that would be like Turtlebot, right?
Yeah.
So if I had all the money, I would probably say, hey, go buy a Turtlebot and get Turtlebot fired up.
That is a good point about the simulator, because then you don't have to have a physical vehicle, because somebody has simulated a vehicle that's ready to go. So that leaves out half of the problem right there. You don't have to get a little vehicle and make it ROS compatible, because there's something that's preloaded on the simulator that says here is a vehicle, whether it be a lawn tractor or a full-size tractor or a Turtlebot or whatever. You can drop the things in there. So I guess yeah, that cuts out half the problem right there. If you have a simulator that's configured, and ideally you want that good dividing line between the simulation and your actual control program, and that way at any point you can break that link and put in a physical robot as opposed to the simulator, as long as you have the dividing line there, so you don't get stuff too intertwined in there.
The people that said, hey, we're interested, how would you characterize their current skills?
Technically capable. It's just amazing. It's amazing how many skills you have to have. There's all sorts of little gotchas everywhere, and you don't think about it. Just hard, like Jeff was saying, it's hard to start from zero. It's just like in Linux, it's weird when you plug in a joystick, and let's say you need to know what port it's coming in on. you know? Well, how do you do that? You know, and then you have permissions issues, you know. I mean, just reading a GPS is fascinating. You got to plug that thing in. If you don't have permissions, you're going to spend 4 hours trying to figure out how to do that. And then if you don't know what port, how do you even find a port, you know? And then you got baud rates, and then you're seeing this data. It's like, wow. You forget that you had to struggle through each one of those steps, you know, 100 or 1,000. So now you may already have your environment set up so it's easy, or you just know what to do. You forget what if you know, what it was like each step of the way. But if you've been monkeying with this stuff since you're a kid, it's different.
As far as all of those little gotchas like that, like say if you load that Lino Robot software onto a Raspberry Pi, does it have all this stuff figured out, or do you still have to go through and, you know, anytime you're going to add a new sensor, you're going to have that problem. You know, as soon as add anything new, you're going to have that. But it just seems like if the thing you're loading on is pre-configured for whatever, you know, here's a list of things that it will run with these things, then you could go ahead and use that. And then when you add the new sensor, as he added a new GPS on there, yes, you do have to go through all the permissions and ports and figure out all that kind of stuff. So and the other thing is, you could start off with the concept. You got the simulator, and then you got the code running on the same. So you got ROS running, and you've got the simulator running on the same computer. And I was talking about this dividing line in there. At some point, you can just say, if we wanted to, like sometimes we will put our simulator on a laptop and then plug in Ethernet to another computer, so you could have your Raspberry Pi running Lino Robots code, talking to the simulator, and it's fairly transparent to be able to do that. So whether or not, you know, that would be the next step you could take. So you're still running a simulator. You don't have to buy physical hardware and have all that be ROS compatible, but you can now move over to your Raspberry Pi, and the thing is running, but it's talking to the simulator, thinking that's a real machine out there. So that'd be another step. Now I don't know how much work that would be to get that down to the point where somebody can just load it and run and understand it, but that's yet another path to take.
Yeah, I wrote these to be, as you know, imagine Colin, and to say, hey, how could somebody like Colin start from zero and get to a place further than zero? And you're right, there's a lot of gotchas in each one of these, but you didn't really, I mean, you did stuff in simulation, then you go out and get a Raspberry Pi, you be able to talk to that remotely, you get a Teamsy, I mean, you get a motor controller and you buy a motor. I mean, those are the big milestone steps. I think if you wanted to accelerate somebody through them, you're on a Zoom call with them and walking through, you know, you have some stuff written down and you have a Zoom call explaining as you go. So if you're asking me what's the fastest way to get through those steps, well, I mean, assuming you agree with those steps, the fastest way is do a good job of documenting them and then be there to help them as they're going through that documentation.
Okay, I agree. That would definitely, being able to see somebody that's already been through these steps, understand what problem is happening, and then fix it right there instead of having to search and figure it out yourself.
The other thing that I thought of, and I went out and bought some of those aluminum, I forget what they call them. You see them a lot in 3D printers. The frame that a 3D printer is made out of, they're the
80-20.
I'm sorry?
80-20 extruded aluminum.
I actually think you could come up with a test bed that, you know, would sit on somebody's kitchen table that you could mount the actual motor, you could mount the actual angle sensor, and I mean, you could configure a test bed with robust
Yeah.
part, and go through these steps with, something sitting on your kitchen table.
Yeah, like you don't need, I know it's fun to jump in and get the lawn tractor, but there's a lot of work that you can do before even getting a lawn tractor. And then
Right.
if you did that work, it makes it so much easier. So like you said, if you built a test bench exactly like you have there,
Yeah.
way better.
I mean, so you can get pretty darn far with stuff that will sit on your kitchen table.
Yeah.
I mean, you may recall I tested this weight, scale and hooked it up to the transmission, the super servo. I mean, you can do all of that on your kitchen table.
Okay.
And I in my head, imagined, those, what is it, T8020? Is that what you said?
It's just 80. I've heard it called 80/20, just
80/20. You could imagine a frame with that and the motor, and so real live components that you're ultimately going to use, all on one thing that sat on a, on a 4-seat tabletop. But again, it goes back to, for me anyway, my input would be along the lines of, start virtually and then slowly move into the physical world.
I think that's good to point out, that command velocity goes from your computer to your robot, and odometry comes back. And that's just a term, it's position, and that's kind of the dividing line between the two.
And back to your concept about building a little simulator to put on your table, a physical simulator, that Brian Tischler that did the Ag Open GPS, early on he built a device that would sit on his table that had an Arduino and it had a steering motor and it had some other devices right on that thing. And then later he switched over and he just put his simulation right into the software. So you just click a button that says turn on the simulator, and he's got extra code running in the background that does that kind of stuff. But if you dig back through his videos, some of his early stuff, he had, he shows you his little board that he had hooked up, and that's the first thing that he was doing. Rather than having the full-size tractor, he just had something on the table that had motors that would turn, and then somehow it send back a signal saying, here's my angle I'm turning at. So that, that's one example of somebody going down that path and actually doing something like that. And then the fact that he then later on thought, I could just do this in software. So you click a button right on the screen and it puts in simulation mode. So just by clicking a button, it's basically does all that stuff in the background for you.
Okay.
Unfortunately, guys, my day job is getting in the way, and I'm going to have to scoot. But so I'll be pitting this weekend. My expectation is I'll be abandoning my pit and going back to the KI, Matt. But that's just my guess.
I'll check in with you. We'll get it. We're too close now.
Thank you for that. Got to run. Have a great weekend, guys.
Okay, see you.
Yep.